Hello, these are the video solution answers to the reactions workshop. Let's look at question 1. So in the first part of question 1, you were asked to recognise which alkali metal is reacting in which beaker. So if we remember when we first covered this in the first video of the reaction series, we specifically looked at the reactions of lithium, sodium and potassium in water. In the video, we discussed how the reactions for both lithium and sodium were similar, but sodium is lower in the group, so therefore would react more aggressively and quickly. Looking at all the options, B and D are the most gentle. This would mean that lithium would be the least reactive, making it beaker B, as it only has gentle fizzing. Sodium, therefore, would be beaker D, as it moves around the surface and fizzes a little more violent. C gives us a vital clue that there is a lilac flame. In the video, we discussed how potassium moves more violently around the surface and it can self-ignite to give a lilac flame. Remember, potassium gives a lilac flame test, so clearly the answer for beaker C would be potassium. While rubidium has been narrowed down to be beaker A, we could apply our knowledge that reactivity increases down the group, and since rubidium is one of the last elements of the group, just as we would expect, it would move the most violent, as explained in the description. This also helps us when we answer part 2 of the question. Since cesium is below rubidium, you can expect a more violent reaction or explosion than rubidium. As long as you emphasise that the reaction would be more aggressive and violent, you would achieve the mark. Part 3. In terms of safety, generally you should know a safe working practice in the lab. Any of the following answers would have been acceptable. Safety goggles, wearing gloves, using a fume hood, using a small piece of metal, a safety screen, and excess water are specific examples of how you could make this reaction safe. For part C, you were asked to underline the formula of sodium oxide out of the following list. The answer would have been Na2O. If you think about ion exchange, oxygen has a 2- charge and sodium has a +1 charge, meaning that for every one oxygen there would be 2 sodium answers, ruling out the other 3 possibilities. Part D. Sodium reacts with chlorine gas to form a metal chloride, in this instance, sodium chloride, as stated in the question. This would mean that the answer could be C or D. D forms sodium dichloride, which is not what you would expect when you form a metal chloride, ruling out this answer. C has the correct product and has a coefficient in front of both the sodium and sodium chloride, making it fully balanced. This would be the correct choice. Question 2 is a direct recap of the second reactions video. It is important you remember the colour precipitates that the halides form. So, bromide is a cream or off-white colour, and iodide is yellow. Moving on to the higher tier questions. Question 1 is recalling the alkali metals in water. The possible answers could be that a similarity would be that they both float because the densities are less than water or less than 1. They both fizz because hydrogen gas is formed, but gas formed would have been enough. They both move, again because hydrogen gas is formed. Some differences would be that we know potassium burns, but lithium doesn't, because potassium is more reactive. Potassium moves more and a lot quicker, because again, it's more reactive. And potassium melts, but lithium doesn't. This is because lithium has a higher melting point. For the second part of this question, you are asked to give the balanced symbol equation of lithium and oxygen. You're rewarded 1 mark for correctly identifying the reactants, which are lithium and oxygen, and 1 mark for identifying the product, which would be Li2O. The final mark would be rewarded for the correct balancing of the equation. So, the reactants have 2 oxygen, but the products only have 1 oxygen. Therefore, a coefficient, or a big number, of 2 needs to be added in front of the product. This now makes 4 lithium atoms on the product side, but the reactants only have 1. So again, a coefficient of 4 would be required in front of the Li to make it fully balanced. In question 2, you're given a table of results of compound A, B, and C, with 2 types of tests that were performed to try and identify the compound. Compound A gave a red flame test and a white precipitate. We know that a red flame test is lithium and a white precipitate is chloride. Compound B gives a yellow flame test and a cream precipitate. We know yellow flame test is sodium and a cream precipitate is because of bromide. Finally, there is a lilac flame for compound C, and we know this is potassium, and a yellow precipitate indicates iodide. The answers are A, lithium chloride, B, sodium bromide, and C, potassium iodide. Part 2 asks for the ionic equation of this reaction. So, silver ions plus chloride ions goes to silver chloride. Don't forget the state symbols. So, silver ions are aqueous, chloride ions are aqueous, and silver chloride is a solid. Question 2b. When W was added to sodium bromide solution, a displacement reaction occurred. This means that W needed to be able to displace bromine. If you refer back to the table of Group 7 displacement reactions in video 2 of the reaction series, we know that bromine can be displaced by either chlorine or fluorine. So W is either chlorine or fluorine, and X is bromine. When W was added to the Z- ions, no reaction occurred. This means that W was not able to react with Z-, and from the table in the video, we can see that this is seen with fluorine, so therefore Z- is fluorine, as no reaction occurs. This makes W fluorine. This is confirmed when W is added to sodium iodide solution, where W plus ions are formed and the halogen Y is left. Chlorine can displace iodide easily, meaning Y is iodine. This leaves X to be confirmed, which, as it can displace iodine, means that it would be bromine. The second part of the question is asking for the balanced symbol equation for iron wool burnt in fluorine to give iron 3 fluoride. For this, we need iron, fluorine, to make iron 3 fluorine. But this is not balanced. To balance it, we need coefficients 2, 3, and 2. Check, we have 6 F atoms on the reactants and the products. There are 2 iron on the reactants and the products, so therefore this reaction is balanced. Question 3 is asking for 2 similarities and 2 differences between potassium and lithium in water. Some similarities you could have listed would be they both float, they both move, they both bubble, they both produce hydrogen gas, and they both form hydroxides or alkaline solutions. Some differences would be that potassium ignites and burns, potassium bubbles and moves more rapidly, and potassium is more reactive. The second part of the question is asking for the reaction between potassium and water and to give a balanced equation. So potassium plus water goes to potassium hydroxide and hydrogen gas. Again, this equation is not balanced as you have 3 hydrogens on the right hand side, but there are only 2 on the left. There are 1 potassium on either side and 1 oxygen. So to balance this, you need 2 potassium, 2 water, and 2 potassium hydroxide. Question 4 is a long answer question where a student is investigating the relative reactivities of the halogens using the elements and solutions of their halides. It's asking you to state and explain the observations made and how the results can be used to determine the relative reactivities of the halogens. You must include equations in your answer. So first, let's look at the observations you would see. Sodium iodide turns brown with both chlorine and bromine. Sodium bromine turns orange with chlorine. And no reaction would occur when iodine is added to sodium chloride or when sodium bromide is added to sodium chloride. The conclusions you can make is chlorine displaces both bromine and iodine from bromide and iodide solutions, so therefore chlorine is more reactive. Bromine displaces iodine solution and therefore bromine is more reactive than iodine. More reactive halogens displace less reactive halogens from a solution. So the reactivity is chlorine is more reactive than bromine and bromine is more reactive than iodine. The equations that you should have included are Cl2 plus 2NaBr goes to 2NaCl plus Br2. Cl2 plus 2NaI goes to 2NaCl plus I2. Br2 plus 2NaI goes to 2NaBr plus 2I.